Hello, today we talk about suffix array. Suffix array is a powerful data structure that can be used to solve different problems about strings. So what is suffix array? Let's take some string. For example, we have string s equal to a, b, a, b, b, a, like that. Now let's write all the suffixes of this string in lexicographical order. So what we'll have? So first we have empty suffix, then we have suffix a, then we have suffix a, b, 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 a, then we have suffix a, b, b, a, then suffix from b we have b, a, b, a, b, b, a, and finally suffix b, a, b, b, a. So we have 6 here, 6 here. Yeah, fine. So this sequence of suffixes is called the suffix array. So how we store all the suffixes? If we store them in an array as strings, the total length of all the suffixes is about n squared, so it's too much. So now instead of storing the strings themselves, we will store for each suffix only the index of the first letter of the suffix. So if we enumerate letters of the string from 0, like this is 0, 1, 2, 3, 4, 5, and then 6, then each suffix can be uniquely identified by the index of the first letter of the suffix. For example, this empty suffix starts from here, so it has index 6. This suffix has index 5. This has index 0. This starts from here, so it's index 2. This has index 4. This has index 1. And this has index 3. So this array of integer corresponds to the suffix array of the string. So this array will be the suffix array of the string s. So how to build this array of integers? Before starting the algorithm, we will do some preparations. These preparations are actually not necessary, but they make the algorithm much easier to understand and to implement. So what are the preparations? First, let's add one special character in the end of the string. So we add special character $, to the end of the string. Dollar will be some special character which is lexicographically less than any character of the string. So what we will have? This dollar will append to each suffix. So we'll have $sign here, $sign here, 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 and here. Now, let's note that this $sign didn't change the order of the strings, because dollar is less than any character of the string. So if we compare two strings, we find the first different character from left to right, and if we go to the dollar is less than the next character, so this string will be less than the next one. Now, let's make all the strings of the same length. How can we do it? It's done like this. So let's add more character to each string using the next characters in the cyclic string. So after $, let's add all the characters of the string from left to right to make some kind of cyclic string. So for example, here we have $, and then we start from left. Let's add A, B, A, B, like that. And do it to all suffixes. So we have here we have A, B, and we have A, B, A, B, B, A, B, A. Now all the strings have the same length. And the order of strings didn't change again. because we add all the characters after the dollar sign. Now, if we compare two strings, again, we go from left to right until we reach the character which is different. But we cannot go after the dollar sign, because dollar sign is strictly less than the next character. So when we compare again two strings, we go from left to right, find the dollar sign, and don't go next to the right. So the order of the strings will be the same. Okay, now instead of sorting the suffixes, we get the following problem. We have some cyclic shifts of the initial string, and we need to sort these cyclic shifts. Okay, and the final preparation will be like this. We will make the length of all strings the power of 2. We can do it by simply adding more characters to the right, using the next character in the cycle. So we go from left to right, and here after character A we have character B, so we add one more character here. And now the length of the string is 8, which is power of 2. And again, we do it to all strings. So we have A, B, A, B, A, B, B. We have A, B, A. Here we have A, A, B, A. Here we go. That's all preparations. Now, what we should do? We need to sort the strings which are the cyclic shift of this string with addition to some additional characters, such that the total length of the strings is the power of 2. How can we do it? Now we will build basically this table by columns from left to right. So each time we'll increase the width of the table by 2. So first we start with only building the first column of this table. Now we build 2 columns, 4 columns, and so on. So we have several iterations on iterations k. So after iteration k, we will build the first 2 in power of k columns of this table. So what are these columns? These columns are basically the sorted strings. Of the following form. So it's strings from character I to I plus 2 in power of k minus 1, like that. Here I assume that the string is cyclic, so this index may be after the right end of the string, but if it's after the right of the string, I assume that we have all the same characters in cycle to the right. Okay, now let's start from the beginning. So what is the base? So the first iteration is when k equal to 0. If k equal to 0, we need to sort strings of length 2 in power of k, so it's 2 in power of 0, it's 1. So we sort strings like s from I to I. This is basically a string of length 1, so it's only one character. So what we can do, we simply can use any sorting algorithm, like merge sort algorithm, quick sort algorithm, and so on, and make this sorting in n log n time. Use any sorts in let's n log n time. Basically, you can use the sorting algorithm which is built in your programming language, like merge sort or team sort or anything like that. Now the interesting part. We need to make a transition. From k to k plus 1. And that's interesting. So what we have here. On previous iteration, we have sorted strings of length 2 in power of k. And we need to sort strings of length 2 in power of k plus 1 using this sorted array. So how can we do it? To sort these large strings, we will simply try to compare two strings of length 2 in power of k plus 1 first. So let's look on two strings which length is 2 in power of k plus 1. So this length is 2 in power of k plus 1. So let's have two strings, string A and string B. So let's split both strings into two parts, left part and right part. So each part has length 2 in power k. So we have 2 in power of k here, 2 in power of k here. Now, how can we compare these two strings? We will do it in the following way. We will compare the left halves of the strings and then compare the right parts of the strings. So if the left parts of strings A and B are different, so if, for example, this left part of A is less than the left part of B, what does it mean? It means that we have some common prefix here, and then we have some different characters. So we have some character A here and some character B here. And this character is less than this. But it basically means that the whole string A is less than whole string B. So if left part of A is less than left part of B, it means that the whole string A is less than the whole string B. Now, if left parts are equal, so if left part of A equal to the left part of B, if they are equal, we need to compare the right part of the string. So let's compare the right part of A and right part of B. So if they are not equal, so for example, if this is less than this, then again we have some common prefix here and some different character here. This means that the string A is less than string B. So if left parts are equal and the right part of A is less than the right part of B, it means that the string A is less than the string B. That's all. Now we have the following comparator. So if A is less than B, if and only if one of the two conditions. So if the left part of A is less than the left part of B, or if left parts are equal, and the right part of A is less than the right part of B. Good. Now, if we learn how to compare two strings of length 2 in power of k, we can use this comparator to compare two strings of length 2 in power of k plus 1. But how can we compare two strings of length 2 in power of k? Okay, we will use the results from the previous iteration. So on previous iteration, we already sorted all the strings of length 2 in power of k. So now let's use this sorted array to make this first comparison. So how can we do it? We'll simply do it in the following way. We take the array from the previous iteration. So on iteration k, we have the sorted array of strings like this. So strings of length 2 in power of k. Now, to compare the strings first, we will replace these strings with integers, such that the smallest integer corresponds to the smallest string. And after this, we will be able to make all these two comparisons in a constant time. For example, let's take on this example again. For example, on iteration k equal 1, we sorted the strings of length 2. So we build first two columns of this table. So we have strings like that. So we have $A, $, AB, AB again, BA, BA, and BB. So on iteration 1, we build this array. Now, let's build the following numbers. So we will replace all the strings with numbers such that the smaller number corresponds to the smaller string. So how can we do it? We simply go from top to bottom, and each time we assign the new integer. So if the two strings are equal, we assign the same integer. If it is greater, we assign the next integer. So we go from top to bottom and build something so. So this will be class 0, this will be 1, will be 2. These two strings are equal, so they have the same integer. These two strings are different, so we get the next integer. So it will be 3, and this addition will be 4. These integers are basically like the classes of the equivalency classes of the strings. So if we split all the strings into some equivalence classes, this will be the number of the equivalence class corresponds to this string. Now, if we need to compare two strings, for example, if we need to compare strings, let's say we have string AB, AB, and string AB, BA. So we have two strings of length k plus 1, 2 in power of k plus 1, so it's of length 4. And we need to compare these two strings. So what we do? We split each string into two parts. So we have this part and this part. And now we replace each part with corresponding integer. So AB have class 2, AB have class 2, here AB have class 2, and BA have class 3. Now, to compare the strings, we simply need to compare these two pairs of integers. So we compare this pair of integers, this pair of integers. This pair of integers less than this, and it means that this string is less than this string. That's basically all. So the whole algorithm works like this. We start on phase k equal to 0. We take these strings and use any sorting algorithm to sort the strings in n log n time. Now, to make transition from k to k plus 1, we take the array of strings from previous iteration, build these equivalency classes, and then use this comparator to sort the strings of length 2 in power k plus 1. So, what is the total time complexity? So, the total number of iterations will be log n, because we end algorithm when 2 in the power of k is greater than n. So, we do all these transitions until 2 in the power of k will be greater or equal to n. So, the total time complexity will have log n iterations. And on each iteration, we simply make the sorting algorithm. So the time complexity of sorting algorithm is n log n. So the total time complexity in n log n. So total time will be n log square.